Good morning, ladies and gentlemen. It's a cool, rainy morning in Santa Barbara, and we're in the Schepanski workshop doing physics lessons for students, basically at the 5th, 6th grade level. I'm primarily doing this for my son, and I want to review a little bit now because life is starting to get a tad bit more complicated. We're going to start talking about AC, or alternating current circuits. And I don't want to give the impression that DC, like this battery, is always safe. There's a word called voltage, and it's the voltage that determines whether something is safe or unsafe. This is a 12-volt battery. The voltage is so low that even though there's a tiny bit of current going through my body, when I short circuit my body across these terminals, I can't feel it. However, if this was a 100-volt battery or a 200-volt battery, I could never do that. It would be just as dangerous as alternating current. I'm going to start talking about how we get alternating current, and that involves quite a few more ideas that we'll have to add on to what we already know. But since I'm going to be working with alternating current in the shop here, that alternating current comes from a wall plug that turns on my lights, turns on my switches, runs everything in the shop, and that's about 120 volts. That's a high enough voltage that it can do serious damage. So it's not that DC is not dangerous, it's just that normally we don't have high voltage batteries. The high voltages come when we start dealing with alternating current, and there's a lot of reasons why that is a bit more dangerous. Okay, so I want to talk some more about aviation safety. And this device right here is the most dangerous object that I have in my lessons. I hope you can see it. This is a plug that plugs into 110 volts, and the two wires that would normally be hidden under insulations or inside of a switch are exposed so I can work with them. I would never touch my fingers across here because that could kill me actually. The voltage here is high enough that it could send a voltage through my body, or current through my body, that would certainly hurt me or damage me. And I want to illustrate that point. If this was plugged into 120 volts DC, then it would also hurt me. So we want to keep that in mind when we proceed with this demonstration. Okay, voltage is like pressure in a tank. This is a fire extinguisher tank. And if there was 120 pounds of pressure in here, the air would blow out of the end very rapidly. If there's no pressure in the tank, that's the equivalent of no voltage. No air would flow. So when I talk about voltage, think about pressure. Voltage is electrical pressure. And so what I'm going to do today is demonstrate very quickly